Well, we're going to go over what are called independent events this time. And independent events are events that occur where one event does not affect the probability of another event. Now, there's ways that we can tell whether two events are independent, mathematical ways, and that has to do with that conditional probability that we talked about last time. So there's a formula here. Let's look at this formula. This says that if the probability of B given A is equal to the probability of B, or if we switch the letters around, we can say if the probability of A given B is equal to the probability of A, then we know those two events are independent. Now, what does independent mean? Well, let's look at some examples. I've got a standard deck of cards. Now remember, a standard deck of cards has 52 cards, 4 suits, I think it's ES, diamonds, clubs, hearts, and spades. And each of these suits has 13 cards in them. Ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Queen. What's the probability of selecting a diamond from a standard deck of cards, putting it back in the deck, and then selecting a spade from a deck? Is picking a diamond and then picking a spade, are those independent events or are they dependent events? Well, since I put the card back in the deck, picking a spade, the probability of picking a spade hasn't been affected by what I did the first time. So the probability of picking a diamond is 13 out of 52, or 1/4. I've put the deck back now. What's the probability that I pick a spade? Well, it's also out of 52 now, 13 out of 52. So because I put the deck or the card back in the deck, this probability hasn't been affected by what I did first. Now, what if I didn't put the card back? Well, if I didn't put the card back, the probability of getting a diamond is still 13 out of 52. I keep the card in my hand. Now what's the probability of getting a spade? Well, it's not 13 out of 52 anymore. I have that one card in my hand. Now it's 13 out of 51. So this probability has been affected by what I did here. So when we're talking about independence, sometimes the idea of keeping it or putting it back, sometimes that's called replacing or without replacement, is a good way to tell if events are independent or dependent. What's the probability that a coin will turn up heads on the 6th flip after it's turned up tails the previous 5 times? Well, if I think about flipping a coin, what's the probability that a coin will turn up heads? So it's heads, tails, that's 50%. That's still 50%, still 50%, still 50%. The fact that I've gotten heads 5 times in a row doesn't have any bearing on what's going to happen the 6th time. So this example is an example of independent events. What happened the 6th time doesn't have anything to do with what happened the previous 5 times. Here's another card question, and notice in part A, they use the term with replacement, and in part B, without replacement. What's the probability that a heart will be drawn from a standard deck of cards, that means 52 cards, and then a club will be drawn? Well, if I put the card back, then drawing a heart is 13 out of 52, and drawing a club is also 13 out of 52 because I put the card back. I still have 52 cards to pick from. If I don't replace the card, the first go around, it's still 13 out of 52 that I'll draw a heart, but now it's 13 out of 51 because I did not replace that card. So the first example shows independent events. The second one here, these are dependent events because this probability